let's see a problematic session of this concept, that is molality, molarity and mole fraction. Okay, so if possible we can see Henry's law formula also in the problem based on that. Okay, so now see here we have a problem, that is calculate the molarity of a solution containing 5 gram of 5 gram of NaOH in 450 ml solution. Okay, so this is the problem. They ask us to calculate molarity of this solution. Okay, so before going to solve this problem, let's see what are the given things in this problem. Okay, so that's why first we write given. See, you know the formula, that is molarity is equal to WB by MB into 1000 divided by V in MB, right? This is the formula. So based on this formula, let's write given in this problem. First they have given a 5 gram of NaOH in 450 ml solution. That means here 5 gram of NaOH, that is mass of solute, that is WB, it is given 5 grams. Okay, so next you need to calculate MB, that is molar mass of NaOH. Okay, so how to calculate? You know, that is sodium, it is 23, it is 1 here, sodium is 1 here, plus oxygen 16 it is also 1 here, plus hydrogen 1 and it is also 1. Okay, so total 23 plus 16 plus 1. Okay, it means 24 plus 16, it comes out as 40 gram per mole, right? So this is MB. Now we need V. They have given volume in terms of ml, that is 450 ml. Okay, so now you substitute in that formula, that is M is equal to WB by MB into 1000 divided by V in ml. Okay, so now WB, you know, it is 5 gram into 1000 divided by MB, that is 40 into V in ml. So they have given 450, right? If you solve this, that is 5 into 1000, that is 5000. Okay, so now 40 into 450, it comes out as 18,000. Okay, if you divide these two, then molarity is equal to 0.2777. Okay, so it should be in terms of unit, that is molarity. Okay, this is the solution for this question. Okay, that is calculation of molarity. Clear? Okay, we have one more question here. See the problem. Calculate the molarity of each of the following solutions. Okay, here we have two tasks. Okay, so question they have given one, but the target is 2. They asked to calculate molarity only in 2 different situations. Okay, the first condition is 30 gram cobalt nitrate hexahydrated in 4.3 liter solution. This is our first target. Second one, 30 ml of 0.5 molar H2SO4 diluted to 500 ml. Okay, let's see the first one, that is A, that is 30 gram of cobalt nitrate hexahydrated in 4.3 liter solution. Okay, so before going to solve this problem, let's write given of this question, that is 30 gram in 4.3 liter. This 30 gram is WB, so that is WB is equal to 30 gram. Okay, so now this is your solute, cobalt nitrate, hexahydrate. So you need to calculate first molar mass of this one. That means MB is equal to, that is cobalt nitrate hexahydrate Okay, if you calculate the molar mass of this one, you know cobalt nitrate, its atomic mass is 58.7. Okay, plus see here you have nitrogen and oxygen. So nitrogen it is 14 plus oxygen it is 16 into 3 it is there. Okay, that means it is 48. So next term it is twice, that means it is 2 plus. So you know atomic mass of molecular mass of water, that is 18, that is 6 into 8. Okay, so overall now it is 58.7 plus 2 into 14 plus 48, it comes around 62. Okay, plus it is 18 into 6, that is 108. Okay, so now that is 58.7. 62 into 2, that is 124 plus 108. Okay, so now 58.7 plus 124 plus 108, it is 290.7 gram per mole. Okay, so this is the total mass of cobalt nitrate hexaoctet. Now we got M. Now they have given volume, that is volume is 4.3 meters. It's there in meters. It's we need to convert it into ml. That is 4.3 meter into 1000. It gives 4,300 m. Okay. So now we have a formula, that is molarity is equal to Wb by Mb into 1000 divided by V in ml, right? So now Wb it is 30 into 1000 divided by Mb, that is 290.7 into V in ml, that is 4,300 ml. Okay, so now 30 into 100, that is 30,000. Okay, divided by 290.7 into 4,300, it comes around 12,50,010. Okay, if you divide this 30,000 divided by 12,000, 12,50,010, it is 0.024 mole. Okay, so this is the solution for this one. Okay, so this is Wb, this is Mb, this is V. So formula is molarity is equal to Wb by Mb into 1000 divided by V in ml. If you substitute 30 into 1000 divided by 290.7 into 4,300, it comes out as 0.024 molarity. Okay, so this is the solution for target A. Okay. Okay, now let's see the second target, that is 30 ml of 0.5 m H2SO4 diluted to 500 ml. Okay, so this problem is based on dilution, that is a molarity equation we need to use here. You know that is M1 V1 is equal to M2 V2. Okay, so this is before dilution, this side, and this side it is after dilution, Okay, so before dilution, see here M1, that is 0.5 m, into volume is 30 ml. Okay, so next it has diluted to 500 ml. We have diluted to 500 ml. That means it is V2. We need to calculate M2. Then M2 into 500. Okay. So M2 is equal to 0.5 into 30 divided by 500. Okay. You know 0.5, that is 5 into 30, that is 15 divided by 500. We have the, okay. That means M2 it gives 15 divided by 500, that is 0.03 molar. Okay, so this is one more solution for the target B, that is 30 ml of 0.5 m H2SO4 diluted to 500 ml. Okay, like this higher concentrated solutions can be diluted by adding water or a suitable solvent. Okay, so let's see the next question, that is, okay, here we have one more problem based on molarity calculation. Okay, see here, calculate the amount of benzoic acid. Here they ask to calculate amount of benzoic acid. See here benzoic acid is a solute required for preparing 250 ml of 0.15 m solution in methanol. Okay, that means benzoic acid is dissolved in methanol to prepare a solution. Are you following? The concentration of that solution is 0.15 m. Okay, they are going to prepare a solution of volume 250 ml. Okay, for that preparation they ask you to calculate the amount of benzoic acid. That means they are asking us to calculate WB, that is amount of cell. Okay, what all things they have given? First they have given benzoic acid. Let's calculate the molecular mass of benzoic acid, that is C6H5COOH. Okay, that is C6H5COOH. Okay, C6H5COOH. Here carbon is 6 plus 1, that is 7. Okay, that means 7 into 12 plus here hydrogen 5. This is 1, that is 6 into 1 plus here we have oxygen, that is 16 into 2. Okay, so 12 7 is 84 plus 6 plus 15 2 is 32. Okay, so 84 plus 6 plus 32, it is 122 gram per mole. Okay, so this is MB. So they have given a concentration, that is molarity is equal to 0.15 m. Okay, so they have given volume, that is 250 ml. 250 ml, right? So now we need to calculate WB. You know the formula, that is molarity is equal to WB by MB into 1000 divided by B, that is in ml, right? So here you need to calculate WB, so that we need to alter this equation, that is WB is equal, so M into MB into V divided by 1000, that is molarity into molar mass of solute into V in ml divided by 1000. Okay, so now let's substitute. WB is equal to molar mass. How much it is? That is 122 gram per mole into sorry, this is molarity, no? So molarity is 0.15 and this is molar mass, that is 122 gram per mole into volume, it is 250 divided by 1000. Okay, so now WB is equal 0.15 into 122 into 250, it is 4575 divided by 1000. Okay, so 4575 divided by 1000 gives 4.575 mass of solute. That means it is gram. That means 4.575 gram of solute required for the preparation of 0.15 m solution of 250 ml. Okay, so here benzoic acid is dissolved in methanol. Clear? Okay, we have one more problem here. So this is now based on a equation, that is a molality equation. Okay, you know molality, that is small m is equal to number of moles of solute dissolves in 1 kg of solvent, right? So that's why molality is equal to number of moles means Wb by Mb into 1000 divided by Wa, that is mass of solvent in kg. Okay, so if they have given in terms of gram, then it is Wa divided by 1000. So if it comes here, then it is 1000 divided by Wa. This is the formula to calculate molality. Clear? So now we have a problem here. The problem is calculate molality of 2.5 gram of ethanoic acid in 75 gram of benzene. That means here benzene is a solvent and ethanoic acid is a solute. Okay, so now let's write the given here. So given, that is Wb mass of solute. So Wb is equal to 2.5 gram. Okay, that is ethanoic acid. So now Wa they have given, that is Wa is equal to 75 gram. Here benzene is solvent, right? Mass of solvent they have given, that is 75 gram. That is Wa is equal to 75 gram. So now we need to calculate Mb here, that is Mb molar mass of solute. They have given it is ethanoic acid, that means CH3COOH, right? So here carbon 1, 2, that is 2 into 12 plus. See here hydrogen 3 plus 1, that is 4, that means 1 into 4, right? Plus here you have 2 oxygens, that means 16 into 2. Okay, so now 12 are 24 plus 1 into 4, 4 plus 32. This is 24 plus 4 plus 32. It is 60 gram per mole. This is molar mass of solute. Okay, so now we got all these three, right? Now we calculate by substituting in the formula, that is molarity is equal to Wb by Mb into 1000 divided by Wa in grams. Okay, so here Wb is 2.5 into that is 1000 divided by Mb, it is 60 and Wa it is 75, right? So now 2.5 into 1000, so you know that is 2500. Now 60 into 75, 60 into 75, it is 4500. Okay, so now 2500 divided by 4500, it comes around 0.556 mole. Okay, so this is the solution. So molality of this solution is 0.556 molar. Okay, you should not forget to put unit. Without unit, lose your marks. Okay, so this is one of the example, NCERT in-text question example for molality equation. Okay, let's have one more. Okay, we have one more problem on molality. See here, if the density of some lake water is 1.25 gram per ml. Okay, they have given a density of lake water, that is 1.25 gram per ml, and contains 92 gram of Na plus ions per kg of water. That means here we have a water. Okay, so in that water amount is, that is per kg. That means 1 kg. Okay, so 1 kg means that is 1000 grams. Here, so in case of the solute is 92 gram. So here solute is Na plus ions. Okay, it is there in terms of 92 grams and it is dissolved in 1 kg of water. They ask you to calculate the molality of Na plus ions in the lake. Okay, first write given, that is it is mass of solute, that is Wb is equal to 92 grams, right? So ions per kg of water means it is a mass of solvent Wa 1 kg. Okay, so we need to convert this one into grams. So into 1000 means that is 1000 grams, right? Now molar mass of solute. Here solute is sodium ions, that is Na plus ions, right? So sodium, its atomic mass is 23 gram per mole, right? So now we need to calculate molality, that is molality is equal to Wb by Mb into 1000 divided by Wa, right? So Wb, that is 92 into 1000 divided by Mb, that is 23 into Wa 1 kg, that means 1000 grams. Okay, this 1000 and 1000 will get cancelled. 92 divided by 23. Okay, that means 23 fours, it will get cancelled. That means 4 molar. Okay, so this is the solution. So this is Wb, this is Wa, and this is Mb. This is the formula. If you substitute all these given in this equation, you are going to get the molality of solution, that is 4 molar. Okay, so this is one of the problem on molality. Okay, now let's see a problem on mole fraction. Okay, mole fraction formula, that is if you want to calculate the mole fraction of component A, then Xa is equal to Na divided by Na plus N, right? For calculating component A, I mean it may be a solvent. Okay, if you consider it. So if you want to calculate the mole fraction of solute, that is Xp, then it is Nb divided by Na plus N. Okay, these are the formula to calculate mole fraction of component A or component B in a solution. Okay, so now they have given a problem. So problem is calculate the mole fraction of ethylene glycol. Ethylene glycol, that means C2H6O2, that is CH2OH. Okay, so this is ethylene glycol in a solution containing 20% of C2H6O2 by mass in water. Okay, they have prepared a solution of ethylene glycol in water. Okay, so here they have given a amount of substance, that means solute dissolved in this solvent, that is 20%. They have given in terms of percentage. Okay, so 20% of C2H6O2 is dissolved in water. Okay, so now how to calculate this? See, before going to this one, let's see this percentage. 20 gram of ethylene glycol dissolved in 100 gram of solution. Okay, so this is the meaning of 20% ethylene glycol. Okay, if it is 20% ethylene glycol means, so 20 gram of ethylene glycol dissolved in 100 gram of solution. That means Wb, that is ethylene glycol, is 20 gram, right? So if you want to calculate mass of solvent, see, if you want to calculate mass of solvent, you need to remove the solute which are present in a solution. Okay, this is solute. Okay, So and this is the solvent. These two combines together to form a 100 gram of solution. That means you need to remove this 20 gram of solute from solution. Then the mass of solvent will be 80 gram. Okay, so this is WB and this is WB. And if you want to calculate molar mass of solute, that is ethylene glycol, we have seen the formula. Okay, so here you have C2, that is 12 into 2, that is 24. This is 6, this is 32. It comes around 62 gram per mole. Right? You can calculate, no? Not a problem. Right. So now MA, that is mass of solvent. So here solvent is dissolved in water, that it as water. That means mass of solvent is, you know, hydrogen H2 plus oxygen 16 plus 2 18 gram per mole. Okay, so now let's calculate number of moles of ethylene glycol, that is C2H6O2. Number of moles means mass by molar mass, WB by MB. So WB by MB, that is WB it is 20 divided by 62. So 20 divided by 62, it is 0.322. Clear? So now if you calculate the number of moles of water, that is number of moles of H2O, then WA divided by MA. So WA, you know, that is 80 divided by 80. So it comes 4.444. Okay, this is mole fraction of ethylene glycol. This is mole fraction of water. Okay, these are these two values, that is number of moles. Okay, now they asked to calculate what? They asked to calculate the mole fraction of ethylene glycol. That means they wanted to calculate the mole fraction of solute only. That means mole fraction of solute. So solute here it is C2H6O2. Okay, is equal to, I have already given an equation for mole fraction. That is, if you want to calculate the mole fraction of component B, that is solute, then N of C2H6O2 divided by N of C2H6O2 plus N of H2O. This is number of moles of solute and solvent, and this is number of moles of solute. So now X of C2H6O2 is equal to, see here, N of C2H6O2. So this is the value, that is 0.322 divided. So this is number of moles of water. Okay, so that means 0.322 plus 4.444. So now C2H6O2 is equal to 0.322. See here, 0.322 plus 4.444, it is 4.756. Yeah. So I will divide. So if you want to calculate number of mole fraction of component ethylene glycol, then 0.322 divided by 4.756, it comes around 0.0675. Okay, so for mole fraction there is no unit, because this is also number of moles, this is also number of moles, it will cancel each other. So that's why you don't have any unit for mole fraction. So you know already that is mole fraction, it gives information regarding only component, not the whole solution. Okay, so this is the solution for this whole problem. Okay, so it's all about problems on molarity and mole fraction. So I am going to give one one homework for your assignment, that is based on mole fraction. Okay, you go through this and solve that problem. Okay, thank you. Okay, now let's see a problem on Henry's formula. Okay, that means on Henry's law. Now we are going to see one simple problem. Okay, so let's have a look on this. The statement is, the question is, Henry's law constant for the molality of methane in benzene at 298 Kelvin is 4.27 into 10 to the power of 5 mmHg. Okay, so calculate the solubility of methane in benzene at 298 Kelvin under 760 mmHg. Okay, so what they ask you to calculate means, that is a mole fraction. Okay, that means the solubility of methane in benzene at 298 Kelvin under this pressure, that is 760 mmHg. Okay, so in this we have a given data, that is Henry's constant, and this is partial pressure of that gas. Okay, so now P of, here it is a methane, that means P of CH4, that is a partial pressure of methane gas is 760 mmHg. Okay, so this is given. We need to calculate the solubility of methane in benzene at this pressure. Okay, that is partial pressure of methane gas is 760 mmHg. Okay. Next, they have provided with Henry's constant, that is Kh. Okay, so its value is 4.27 into 10 to the power of 5 mmHg. Okay, this is Henry's constant. Make sure this value will differ for different types of gases. It is not same for all gases. Okay, so now next we need to calculate CH4, that is solubility of gas. Here it is mole fraction of methane, that is question mark. Okay, from Henry's law, you know the formula from Henry's law, you know that is P is directly proportional to mole fraction. So that means P of CH4 is equal to Kh. Here it is a constant. Okay, so X of CH. So this is the formula for this particular problem. Okay, now we need to calculate this solubility of methane. That means X of CH4 is equal to P of CH4 divided by Kh. Right? So here they have given the value of PCH4, that is 760 mmHg divided by, here you have a Kh value, that is 4.27 into 10 to the power of 5. Here, now if you divide 760 divided by 4.27, then it is 177.98. So 760 divided by 4.27 comes out as a value 177.98. Okay. So one more thing, here you have 10 to the power of 5. Okay, denominator. If it comes up, then it becomes 10 to the power of minus 5. Okay. So now the value is 177.98 into 10 to the power of minus 5. If you shift this point to write in scientific notation, then it is 1.77, okay, into 10 to the power. See, it is minus 5 here. So now we are shifting 2 points, that means 1, 2. Okay, then if you remove 2 from this one, then it remains with minus 3. So this is solubility of CH4, methane. Okay, so this is the solution for this particular question based on Henry's law. Okay, so in the next session we will see the continued part of this one. Okay, and again, as I told you in the earlier, you need to present your assignments as soon as possible. Okay, so until then, thank you.